Hello everyone, this is Steve. Thanks for joining me. When we have this system of nonlinear equations here, which is actually going to be an ellipse and a hyperbola, our goal is to find any and all ordered pairs where they intersect. So let's go ahead and get started by trying to find a way to create an equation with only one variable. So what I'm going to do, everyone, is I'm going to take the first equation, I'm going to multiply everything by 3. So we're going to do times 3. And if I do that, I'm going to get 9x squared plus 15y squared equals 51. Now the reason I'm doing that, everyone, is because if I multiply the second equation by 5, then I'll have a 15y squared in the first equation and a negative 15y squared in the second equation, and when I add them together, the y squareds will go away. Check it out. If I do this one times 5, then I get 10x squared minus 15y squared equals 25. And then we can just add them together and the y squareds will go away. It's pretty cool. So, add them together, I'm going to get 19x squared equals, looks like that's going to be 76. Okay, now we divide both sides by 19, and we get x squared equals 4. Now, we do need to apply the square root property, and in this case, x could be positive or negative. So when we apply the square root property to both sides, we do get that x could be plus or minus 2. Now we take plus and minus 2 and we plug them back into either one of the original equations to try and figure out what y is going to be. So I'll take this first equation right here and I'll try plugging a plus 2 and a minus 2 in there. So if I plug a 2 in there, what's going to happen? Well, I'm going to get 2 squared is 4 times 3 is 12. Plus 5y squared equals 17. Subtract 12 from both sides. 5y squared equals 5. Y squared equals 1. Take the square root or apply the square root property. And it looks like I get y equals plus or minus 1. Now here is the sneaky part about this problem. When I plugged in that positive 2 right up here, the first thing I did was square it. So if I plugged in a negative 2, I would have gotten the same answer of y equals plus or minus 1. So that means if you plug in a 2 for x, you get y is either 1 or negative 1. And if you plug in a negative 2 for x, you would have gotten either that y was 1 or negative 1. So we actually get 4 answers to this problem, everyone. The 4 answers we get are 2, 1, 2, negative 1, negative 2, 1, and negative 2, negative 1. We get 4 answers. What we should do with those 4 answers is we should check them in the other equation. We should check them in the 2x squared minus 3y squared equals 5 problem. But here's the idea, everyone. Whether or not you plug in a 2 or a negative 2 for x, it doesn't matter. And whether you plug a 1 or a negative 1 in for y, it doesn't matter. So when you check it, it looks kind of funny, but you can basically check it like this. 2 plus or minus 2 squared minus 3 plus or minus 1 squared, and that is supposed to equal, sorry, I think I could remember the equation, equals 5. So 2 or negative 2 squared doesn't matter, it's going to be 4. 2 times 4 is 8. Plus or minus 1 squared is going to be 1. Minus 3 equals 5. So they do all check. Interesting note, everyone. You cannot just write this for your answer. Because if you write that for your answer, that actually only equates to 2, 1 and negative 2, negative 1. So this is no good. Don't ever do that. What actually just happened here? Well, check it out. This is the graph of the ellipse and the hyperbola we were just working with. And you can see the 4 intersection points on here. This one right here is 2, 1. This one is 2, negative 1. This one over here is negative 2, negative 1. And this one over here is negative 2, 1. So those are the 4 ordered pairs we just found. I hope that helped, everyone. Thanks for watching.